electronic configuration of elements. Electronic configuration. Electronic configuration of electron. Electronic configuration of elements. Electronic configuration of elements. First number. The maximum number of electrons in an orbit. The maximum number of electron in an orbit. It is given by formula. It is given by the formula. It is given by the formula. The formula 2n square. That means for K cell n equal to 1, then the number of maximum electron 2 multiply 1 square equal to 2, and so on. 2 number. Maximum number of electron in an orbital. Maximum number of electron in an orbital. Maximum number of electron in an orbital by the formula. In an orbital, it is given by the formula. Given by the formula 4l plus 2. That means for L orbital. For L azimuthal quantum number, orbitals, and formula 4l plus 2. 4l plus 2. For L equal to 0, azimuthal quantum number 0. For S orbital, that means 4 multiply 0 plus 2 equal to 0. Equal to 2 electrons. For azimuthal quantum number 1 for p orbitals. 1 for p orbitals, then the total number of electrons 4 multiply 1 plus 2 equal to 6. For azimuthal quantum number 2 for d orbital. 2 for d orbital, 4 multiply 2 plus 2 equal to 4 to the 8 to 10. For L equal to 3 for F orbital. 4 multiply 3 plus 2 equal to 4 3 the 12 to 14 electrons. Total number of electrons in F orbital 14. Total number of electrons in d orbital 10, and total number of electrons in p orbital 6, and total number of electrons in S orbital equal to 2. Filling of electron in an orbital. Third number, filling of electron in an orbital. It is in accordance to above principle or n plus L rule. It is according to 1 minute. It is in accordance to above principle or n plus L rule. It is in accordance to above principle. It is according to above principle or n plus L rule. N plus L rule. Orbitals are filling up with electron. Orbitals are filling. Orbitals are filling with electrons. Electrons in the increasing order of their energy. In the increasing their order of energy. Increasing their order of energy. With electron in the increasing order of their energy and decreasing their stability and decreasing their stability. The relative order of energy various orbitals are as 1s is less than 2s is less than 2p is less than 3s is less than 4s is less than 3d is less than 4p is less than 5s is less than 4d is less than 5p is less than 6s is less than 4f is less than 5d is less than 6p is less than 7s is less than 5f is less than 6d is less than 7p. Electrons enter the orbital's minimum energy and only after filling it to the full capacity. Electrons enters orbitals of next minimum energy. If there are 11 electrons, the distribution of electrons are. If there are 11 electrons, then the electron distribution are 1s2, 2s2, 2p6, 3s1. The distribution of electron in orbital of different orbits represent electronic configuration. The distribution of electrons in orbitals of their orbitals of different orbits represent electronic configuration. Electronic configuration. Four number and the 4 number. It also follows Ohm's rule. It also follows Ohm's rule. It also follows Ohm's rule. According to which orbitals are firstly singly filled. Orbitals are firstly singly filled and only after then pairing takes place. then pairing, text, place, text, place. 5 number. That number 5. It also follows Pauli exclusion principle. It also follow Pauli. It also follow Pauli's exclusion principle. Exclusion principle. Exclusion principle. That means this principle states that this principle states that this principle states that no two electrons in an atom can have all the four quantum numbers identical. Four quantum number identical, and the sixth number is 1 minute. Wait 1 minute. Sixth number is, and the sixth number is as energy of n-1 into d, as energy of n-1 into d, n-1 for d orbital is higher than ns, hence ns orbital is filled first. ns orbital is filling first. First, this occurs at K 19, RB 37, CS 55, and FR 87, and 7 number. After filling ns square, ns square, electron enters n-1 d orbital. This occurs at SC21, Y39, and lanthanum 57, and actinium 89, and 8 number. As half-filled orbitals, half-filled orbital is more stable relative to less than half-filled. Relative to less than half-filled. Hence ns square n minus 1 d 4 because becomes ns1 n minus 1 into d5. This occurs at chromium 24 and molybdenum and MO42 and 9 number. Completely filled orbital is more stable. Completely filled orbital is more stable. Orbital is more stable relative to less than complete field. Relative to less than completely filled. Completely filled and half filled orbital is as stable as completely filled. So ns square n minus 1 d9 becomes ns1 n minus 1 d10. This occurs at copper 29, Ag47 and Au79 and 10 number. Last is 10 number. 18 electronic structure. Electronic structure. 18 electronic structure. ns square np6 nd10 is more stable. So PD46 has 4s square, 4p6 and 4d10. Electronic configuration. Instead of 4s square, 4p6 and height s2. In order to get near 18 electronic configuration, in order to get near 18 electronic, in order to get near 18 electronic configuration, 18 electronic configuration, Ru44 has 4s square, 4p6 and 4d7 5s1 IU45 has 4s2 4p6 4d8 5s1 IR77 has 5s2 5p6 and 5d9 and 6s0 and PT78 has 5s2 5p6 5d9 6s1 electronic configuration electronic configuration the electronic configuration of element Z is okay. And next heading we will study about the effective nuclear charge. Okay, thank you.